Hello, my name is Grzegorz. I'm Engineering Consulting Director at NetGuru, and welcome to yet another episode of Disruption Talks, where we invite top experts to discuss digital acceleration, winning strategies, innovation, and scaling products. Our today guest is Fergal Reid, Director of Machine Learning at Intercom. Hello, Fergal.
Hi, Greg. Thanks for having me here.
Our key topic for today is how AI-powered solutions enhance customer support processes. Fergal, I remember that you had quite a great launch recently of the AI-enabled support assistant, which is called Fin. Could you explain a little bit more? What is that? How does that help? How it works?
Cool. Yeah. So Finn is our new bot to customer support bot to answer customer support questions, and we've built it on GPT. We've built it on the sort of the next generation large language models that you're seeing at the moment. Finn specifically is built on GPT-4, so it's using like OpenAI's like top language model, to give it really unparalleled ability to sort of to understand customer questions, to understand the articles in your help center, and to answer questions from those articles in the help center. It's live now in the last few days. In fact, we've had its kind of first wave of thousands of customers kind of starting to be onboarded and invited to it, and yeah, we're scaling it out at the moment.
Cool. One of my first questions is whether you are using Fin internally or not, because I know the hype around AI, generative and AI, like everyone was just jumping on that, and when having developed a solution like Fin, are you using it internally for like internal FAQ or maybe knowledge base?
Yeah, well, so Intercom, the company, actually has a pretty big customer support operation, and we always aspire to kind of make our support as good as possible, to use as much automation as possible in our support. And so we use Fin now as sort of our first line question answering service for our own customer support. So Fin is working. We're eating our own dog food or drinking our own champagne or whatever metaphor you want to use there. Yeah, we're using it. We didn't actually initially do that at launch. And I remember internally in the company, we agonized. We were like, we want to show a demo of Fin. We want to put it live. We want to actually get credibility with people by enabling them to play with a demo of this when we launch it. And we really agonized internally. Should we just have it answer our own support questions? Or should we sort of do a demo on a made-up website? We actually went for a made-up website because we thought like there's going to be people coming to the Fin demo who are not familiar with Intercom and who kind of won't understand whether an answer it gives is good or bad. And so we used sort of an Airbnb style, vacation rental style company, as our demo app. But that time has passed, and now it's actually live for Intercom. It's running our own customer support, running against our own knowledge base, and that's been very good. We've had a very good response from our own customers to it, and we've also built sort of an experience where on day one you can go and you can just enter in a URL of your own website or your own help center, and you don't have to take our word for it. You can sort of like go and play with it yourself, and I think that's crucial for this sort of AI tech. Like, is it good? Is it bad? Is it, are the claims, marketing claims, or hype? And so we've done a lot of work enabling people to like low friction test it out in your own help center and assess it for yourself. So, yeah.
Sounds amazing. This is one of the further questions that I have. So you've mentioned that you can just enter your URL of your webpage, of your knowledge base, of the FAQ and so on, and the bot is able to automatically pick up all the threads that you have out there and answer based on that. How does the quality assessment look like? How do you do that? How do you make sure that those questions are answered correctly and with the right, I would say, kind of communicate?
Yeah, I think it's a great question. And look, this is something we worry about in the market, right? Which is we've gone and we've built this bot. We're using GPT-4 it's sort of the best, and it's the most expensive OpenAI model to run. And you can go and build a bot that uses like GPT 3.5 Turbo instead, and it's going to be like way cheaper to run. But often will hallucinate a little bit more, often will just not be quite as accurate as GPT-4. And so we were like, okay, how are our customers going to be able to tell? Like if we go and we, pay extra money for the most expensive model, how can we make it so our customers can actually see the value of that before purchasing it? And again, that's what's pushed us to build this sort of like bring your own help center, is what we call it internally. Is what pushed us to build that experience. The idea is that you almost have to test these things qualitatively. Like you almost have to just play with them and, try ask them like a hard question. Try ask them a question your help center doesn't answer. Try ask them a question that's similar to a question your help center answers, but is not actually there. And just play with them. And the reason why you have to do it like that is that's really the only way to kind of get the accuracy, the quality of these models has gotten so good that it's getting hard to find the breaking point. And so like you really need a human who understands the real customer support, domain of your company to actually like play with it for like 5 minutes before you're going to get it to push it to breaking point. Once it's live, once you sell it live, there's all the standard metrics that we have in terms of like, hey, how many conversations does this resolve versus how many have to go through to a human. And, we have a suite of metrics for our previous machine learning bots, our previous generation machine learning bots that all sort of work. And so there's a pretty standard patterns for evaluation quality after it's live. But we really sweated that like, pre-live decision, like how our customer is going to be able to tell that this thing is in fact better. And so that's why we ended up building this kind of like even pre-sales experience.
Cool. One of the things that seem quite different to me is you mentioned that you are still using some of those classical machine learning metrics for monitoring the model in production and so on. However, there is this quite huge difference, in my opinion, in terms of how you can evaluate the model before you deploy it. Because in some cases, especially when you had like very simple, classifiers, recommenders, or something like that, you are able to pre-compute quality metrics upfront before you deploy them to production. This can give you some idea, some imagination how it may look like. Of course, it is not super one-to-one. We want it to be, but it is not always one-to-one what we will see in the real life data with the real users, but it should give us some idea. Here, I believe there is this kind of important distinction that we do not have that. Is that the challenge? Is that something that needs your team to change thinking about building such system?
Yeah, interesting question, and I think there's a lot of nuance here. So normally, right, traditionally with a machine learning model, let's say it was a classifier, right, where it was like, hey, we wanted to recommend which article we should give in response to a particular question out of a set of like maybe 5 articles or something like that. It's very easy to sort of to set up a back test where you say like, okay, these are the historical questions. And for each historical question somebody asked, this is the right article. This is the article you should have given it. All right, what would the model have done if we run it, back over those last thousand situations like that? And that's very simple and very, you can set that up. Where things get a bit more complex with these large language models is, they're generating text, they're generative. So they're going to generate an output that you may never have seen before. And, you then have to figure out, okay, is this output a correct answer to this particular question? And how do you do that? Well, you can kind of, you can check to see, is it approximately the right answer? You can use like vector similarity. You can use another neural network to embed this and then calculate if it's roughly the same as the answer you expected. But now, these large language models have gotten so good that we're really dealing and trading in very subtle, is this exactly the same answer or not quite the same answer? And so it's hard to quantify that. And so, you know, we do a bunch of evaluation. We have we have test suites where, you know, we'll run the machine learning model on like 100 or on 1,000 sort of like known questions where we have a correct answer for each of those, and then we can see what the model generates, and we can check to see, okay, is that approximately similar to the answer we expected? And if it is, we'll give it a pass. And we don't know that it exactly answered the question, but we know it didn't come up with something completely different semantically. And then we rely on a lot of manual evaluation. We rely on, like, you know, people on my team who will go and, you know, look at the output of a model over like 50 or questions where we've curated these questions, and we've identified like, these are hard questions. These are questions that are at the limit of the model's understanding. And so, you know, when we're evaluating a change, we're evaluating a new model, we look at that, you know, you can get a pretty good sense whether it's improved or not. And yeah, you know, we rate models along different axes. We're like, is this grounded? Is it relevant? You know, yeah. So we have a pretty built out evaluation strategy, but there's definitely changes because the models are generative. Evaluation is a little trickier than it was for a traditional machine learning system. So yeah.
Okay, that's an interesting thread when you are reaching the limits of such a large language model. I also remember that there was an interview recently with Scott Zoldi from FICO about using those AI tools like ChatGPT or GPT-4 responsibly, for example, in financial services. And there was quite a strong part about the importance of embedding human in the customer-facing decisions, especially due to regulatory limitations. And there were some three elements that need to be fulfilled by such a system, like being auditable, safe, and ethical. I wonder how to find this right balance between those AI-driven case resolution switching to human support. I believe you have that on your webpage already somehow underlined as well. And also you mentioned this part of reaching to the limits of these large language models. And I wonder whether this is this factor that you are using, or maybe some other that should be taken into account designing this kind of an experience.
Yeah. So you know, I think it's a great question. One thing we've done with Finn, and one thing we frequently do at Intercom, is we're sort of, we like to start small. We like to start with, like, you know, a cupcake approach. So, you know, Finn is our bot is designed. It's designed to be a question answering bot at the moment. So it you know, we've deliberately the new part, the part that uses GPT-4 and is generative. We've deliberately made it so that it's just going to answer your questions. It's going to try and just answer questions from your knowledge base. So we've taken on a very constrained but still very valuable task. And what we're not doing with Finn right now is we're not having it take action. We're not having it like issue a refund or you know, reset your password or whatever that action might be. And so, you know, we've gone out with sort of still hugely valuable but initially limited use case, which is like, hey, it's just answering questions based on information that's in the knowledge base already. And we think by constraining it like that, that reduces a lot of risk. It reduces a lot of risk of it doing something that might be unintended. And we've also, you know, limited it to, we've taken a lot of care and attention to build it. Like you can build these bots. If you take Turbo or GPT-4, it's very easy to build them where they're answering a question either just from their own internal knowledge base that they've learned from being trained on the internet, or from a combination of that and some data you've put into them. And we've deliberately limited it to just information from the knowledge base. Like, we consider it a failure of our product if you ask a general question. If you say to Finn, hey, who's the current president of America? And it gives you an answer to that, well, that's a failure, because unless that's in your knowledge base, we don't want it to answer that question. And we think that's the right way to use these products, at least at the moment, because otherwise you'll end up with a bot that will just talk to your customers about anything and everything. And I sort of feel that, you know, the discourse around large language models got misled a little bit. They're trained on all this data, and like that that giving them a huge amount of data was necessary to train them. But what's really valuable about them is their ability to reason. We can use them as little reasoning engines. So we can give it an article, we can give it a question, and then we can say, hey, just use the information here, figure out what the answer is. And they're smart enough to understand the article and to be able to answer that question in a very strong way. And I think a lot of the discourse around them got distracted by oh, it hallucinates, or oh, it knows information that's not quite right. And I'm like, well, we don't care what it knows because we don't want to use what it knows. We just want to use its capabilities as a reasoning engine, not as a store of knowledge. And I think when you use them in constrained ways like that, you start to see them as very powerful tools that you can use that are still quite constrained in terms of what they do. And then it becomes more like traditional machine learning, more like traditional engineering. You've got a tool that's predictable, and then that just makes it much easier to deal with all those issues around being trustworthiness and being transparent and so on, because you can design around. You've got a relatively predictable tool you can now design around.
Okay, so I hear 3 lessons from your perspective already shared. The first one is if we use the large language model properly in the area where everyone talks, that this is one of the biggest limitations, why they cannot interact with the environment and so on. This was the area where you purposefully limited the model to just answer questions, because that was the area where you could control it up to some extent, of course, with the knowledge base that you provided. So this is the first area. Limit all the noise around, limit all the tooling that is available, just make it answer questions based on a specific knowledge base, and voila. So this is the first learning that I see here. The second one is actually to limit the noise coming from the training data, so that you do not use it as a knowledge tool itself, the model, but the knowledge is actually embedded in your knowledge base, and you are using the model just to extract that knowledge. You are not using the model at all in terms of extracting the knowledge that was used to train it, because it will yield more and more hallucinations. And the third one is about constraining how you are able to interact with the bot, because otherwise I believe anyone would be able to use your bot just to play with GPT-4 for free, right? Or actually your customer would need to pay for that, or you, or whoever else. But someone would need to pay for that, but anyone could exploit the system actually. So to prevent cost pumping up, this is how you can do it, just by constraining the bot to focus on your knowledge base answers only, nothing else. That's super interesting. Okay, we've got first question from the audience. Here is the question from Paulina. In relation to Grzegor's question, what do you think about the ideas that call for globally stopping research on GPT models?
Yeah, I mean, so I think it's important to kind of distinguish different things here. So, here's GPT-4. It's a large language model. It's doing token prediction. It's definitely moderately intelligent, right? It's you can ask it a question, you can give it an article, and it will answer the question from an article in a way that is very impressive. It'll pick up on, hey, exactly what this sentence means. We're a long way from machine learning 5 years ago, where it would it contains the same word. So it's very impressive from that perspective. I don't think anyone thinks GPT-4 is a super intelligence and is dangerous on a large scale. Whereas I think the calls for globally stopping research in GPT models are people are worried someone will accidentally build a super intelligence before they're ready for it. And so I sort of think GPT-4 is a really useful tool. I mean, my guess is that GPT-5 and GPT-6 are also really useful tools and not dangerous super intelligences. I do not know that. I don't think anyone knows that. That's speculation. And so I think that the calls for globally stopping research are they're into this area of hey, could you accidentally build a dangerous super intelligence? Now, speaking personally, I think that is something that you can't totally rule out. At least I have not seen an argument that says There is no way we could ever do that as we keep scaling these models up. So speaking very personally, I would not like ban research on models now, but I would start thinking about AI safety, like medium, long term, as people start scaling these things up. I don't think that's a ridiculous thing to think about. I think AI safety is starting to become an important thing to think about. But I think that's like for, that's if someone comes along to try and like radically scale these systems up. I don't think we're in that regime with like GPT-4, and my guess is not anytime, not with GPT-5 or 6. But I don't know, and I don't know how much, this is really a question for the research labs, the people who might, might really want to push the scale of these things up 100x or whatever that might be. So I think it's a legit thing to start debating and start thinking about. I personally wouldn't stop things now, but I would be entertaining the debate personally.
Sure. Well, I saw two more threads in that. At least that were circulating in the media. One of them was that actually we can ban it, sure, but at the same time, who will ban it outside of EU or United States, right? So we would basically just stay behind, nothing else. The research itself globally wouldn't be stopped, actually. So it actually doesn't make much sense to do it on the regulatory level, though this debate would be definitely useful. On the other hand, there is also this more important aspect, I believe, to the entire debate. This is no longer a debate that should be held on the technological level only, because there is quite a lot of questions also on the philosophical level that would need to be answered to make any claims about consciousness of such a model, about whether this is already this kind of intelligence that we expect as a super intelligence or not, and so on and so on. So this goes far beyond just machine learning.
Yeah.
Well, I do not see any structured global initiatives around that. They are much more local than we would like them to see, probably. But well, who knows? Maybe they will develop.
Yeah,
Okay,
I mean,
a follow up.
No, I mean, I think that, yeah, if you want to get into that area, people have to be talking about international treaties and so on to like that's the level that conversation has to be at. And that's definitely above my level politically, but yeah, I think that conversation inevitably goes that way. Yeah.
Sure. I have a follow-up question from Paulina. I totally agree with Fergal when it comes to the super intelligent model. However, that about the increasing possibility of using these tools to spread, for example, fake news or create some kind of disruption in society. And can we somehow prevent it as these tools grow?
I think that for so firstly, I think like it's really important to distinguish like the risk of like a super intelligent model that destroys the world or something like that, the kind of the Elon Musk style thing. I think that's obviously potentially a massive risk. And then there's also there's the normal trade-offs then of like normal technology, which is like, hey, this could create fake news. This could be used to produce spam at scale. Like it could be misused. There's a whole lot of normal trade-offs. Not like I don't know how to think about these things, but trade-offs that are definitely of a lower class of risk than the super intelligence. I think that these are all risks to manage. None of these things like the fake news would stop me saying, hey, we should adopt this AI. This AI overall is like got a lot of ability to automate things for us to remove human labor. Yeah, there's absolutely risk in terms of like people will figure out ways to do bad things with it at scale, like spam, fake news, and so on. Companies like OpenAI, have safeguards on their models, like to try and like monitor and prevent that. But then you're going to see open source models or kind of quasi open source models come along. I think the ability to generate plausible sounding but fake text is going to become just totally widespread at this point. It's going to become a commodity, and we're just going to have to deal with it. And How that will happen, I don't know. I imagine that like if you're, you know, running a social media platform, you're going to care more about, you know, where did this content originate from? How do you verify its authenticity? But I think we've already sort of passed that threshold. I think just, you know, the threshold of like models are good enough to generate plausible but wrong fake news and stuff has been out a while. And yeah, challenges there, but they don't feel relevant to say Fin Intercom's bot, you know, because it's a deliberately constrained tool, and they wouldn't stop me generating large language models. Large language models are just going to be such powerful tools for us to use. The short-term downsides, like fake news and so on, feel smaller, and you know, something to take seriously. But yeah, I wouldn't pause development for that. Speaking personally, and I think it is a political question. Yeah.
Yeah, so it also seems like a race between actually delivering those right solutions, those solutions that would bring benefit, as compared to those bad actors who can exploit these kind of solutions for spreading misinformation. Okay.
Yeah, totally. And just to say as well, like, you know, it's not obvious that this works out in a bad way. It could be that like, hey, large language models are expensive, so it costs you more to produce spam or fake news, and then other people on the other side have large language models to detect them. And you know, that could work out fine. Basically, that could leave us in a better position than we are currently with fake news and spam. So we'll see.
Well, spam usually is supposed to be cheap, and if those models are the more plausible the text produced by those models, the more expensive it is. So maybe that will be a blocker. We will see. Fergal, let's move on to another question. I have the question that if you see any specific industry avoiding tools like Fin for some reason, for example, financial industry, does it avoid Fin or not? Does it sound like a real concern rather an excuse? How does that look like? There is also a question from Sebastian at the same time, very much related. Could you tell which industries are adopting this generative AI the quickest? How those enterprise clients approach this huge change in general?
Yeah, absolutely. You know, so I think like, you know, who adopts it the quickest? You know, Intercom has a lot of customers that are, say, B2B SaaS customers, and you know, they're fast to adopt any new tools. They're like very agile companies from a technological point of view. They've got very agile internal processes. They can adopt tools like this quickly. I think it's sort of, it's too early to tell beyond that. Like, you know, these tools are so new. I couldn't really give a general comment on which enterprises or which sort of enterprise adopt it more quickly. I would say that there's always, you know, customers are always cautious about these things. They're always like, hey, is this real? Is this valuable? Is this hype? How do they tell it apart? And so, you know, that's always in you know, it's the forefront of their mind when they're looking at things like this. Some industries, obviously regulated industries, are more cautious than others. That makes sense. That you know, there's good reasons for that. And I would say that, like, you know, I would say that the potential value here on the table is so obviously high. It's so obviously large to a lot of people. Like, you know, we're seeing Fin go live and sort of like, you know, day one resolve like a lot of people's questions, and in a way that we've never had a tool that's kind of had that performance before, that kind of low friction and then like instant return. And we think a lot of customers sort of are aware that the upside here is very large, and so that's going to push them to like experiment more and to kind of investigate things more quickly. So I expect a fairly quick adoption here. I do think that any of these large language models, they're not 100% predictable. Like, you know, and we've done a lot of work to try and take Fin and make it very constrained. I think we've done a good job at this, but I think individual customers are going to have to look at it themselves. And if you're like I would not use Fin to give out medical information. I wouldn't use it to like do anything to like, you know, anything that could make a decision like that. I wouldn't do. But like reliably answering questions about like resetting your passwords or like managing your accounts or things like that. Yeah, you can like do that, I think, in a way that's like not 100%. None of these models are ever 100%, but very close to 100%. Like we certainly our experience, we're seeing extremely high accuracy, but each individual customer will have to look at it on their knowledge base. Its accuracy is going to change based on your individual knowledge base, based on the sort of questions you get. And so, we encourage every customer to sort of like, look at that themselves and sort of make their own determination. And not because we're trying to like duck the question of accuracy, but just because people's thresholds vary a lot from business to business. Some businesses can accept, very low accuracy. In fact, it's okay. It's no harm if the bot tries to help and it gets it slightly wrong, no big deal, and better than waiting, a long time for human support in 90% of the time. Other businesses can't accept that at all, and like they want something like, I think, which Finn does, which is like very, very rarely gets it wrong. But then some customers are going to like be like, hey, I could just never have any automated system answer these sort of questions. And I think we're going to see interesting dynamics. I sometimes think about the self-driving cars. It's like, what is the standard here to accept a self-driving car? Is it like better than a human, or is it that it never ever makes a mistake? And I think we're going to see something similar with these AI tools, which is like, the reality is that there's a lot of customer support agents in the world who, will make mistakes, will sometimes tell somebody the wrong answer because it's their, first few weeks on the job, or because, maybe it's not a particularly high paid customer support job. And in situations like that, the answer you're going to get from an AI bot is actually going to be very preferable. And so, we're going to see, it's going to vary a lot per business. If you're building like, I don't know, like fun video games, it's going to be a very different question than if you're, in a regulated industry. And so I think we're going to have to see everyone sort of analyze these and navigate these trade-offs.
Out of curiosity, are you monitoring actually how Finn copes with answering questions as compared to human performance? Because this is somehow the threshold, the magical threshold around machine learning system. This is something that we always want to surpass. Maybe not always, but in many cases. Sometimes it doesn't make sense, but in quite a lot it does. Especially that we have this benchmark that, let's say, we can augment the person with this tool quite reliably. We can use it for fixing the errors that people do, and so on and so on. Are you able to actually compare that benchmark to human performance already?
We haven't really done that explicitly, but we've done that implicitly when we're trying to like understand, okay, how good is this? And any bot, any modern bot, anything like Finn, it's a complicated system. There's a lot of different parts of the system. I would say that like, if you ask GPT-4 a question about an article, and if the answer is actually in that article to start with, I would say GPT-4 and the kind of current modern models are human level. I think that's fair to say. Now, if you ask a question about an article and the article is not quite there, sometimes like their common sense or their judgment, or whatever you might call it, is not quite as good as a human. Like sometimes they don't understand the context, and they're working like a few articles at a time. Like they don't understand. So they're really good at like reading something you give it and figuring out the right thing, but they don't deeply understand your business. They're not like, to think of it as like, imagine that there's a human support rep who doesn't know your business, and you just give that support rep a couple of articles and then a bunch of questions, and you ask them to answer the questions. I'd say they're about as good as that, but they're not as good as someone who's like worked in your business for 5 years and understands all the weird edge cases and the things that are in the documentation that don't quite make sense or aren't quite right. They're not that good. So, so human level, it depends. And it's, these are like alien intelligences, right? They're not like they're not the same shape. So like, they're faster and better in some ways and then worse in other ways. They can act very fast. They can read an article very fast. The attention to detail is excellent. We find ourselves a lot looking at examples where somebody has reported an error in Fin, and we look at it, we're like, oh yeah, oh, that doesn't look good. Why did it say this? And we read the article, and we're like, I just don't see it. We read the article again, and we're like, oh no, look, yeah, the article does say that, you know, and it's just, it's like, it's very good at like
It's
comprehension, one pass comprehension in a way that sometimes takes a human like just, you know, 2 or 3, you know, it's, you want to read a full article and understand it, you got to read it quite closely, and the bot does this in seconds, like, so it's a different shape there. That's interesting.
Yeah, it has separate perspective, because you're writing the article, or at least and reviewing the article, you know what you or your company had in your mind writing the article. But actually, if the bot doesn't know it, it may capture another perspective, and the alien perspective, as you mentioned, which may be actually the thing that we need. You mentioned also one important aspect, that I believe you also mentioned previously, that you nailed down already. So if you have knowledge base and there is no information on a specific aspect in that knowledge base, how do you force this GPT-4 to say, I don't know, or this isn't included in the knowledge base? How to do that?
Yeah, so you're into this area of so-called prompt engineering, right? So like you can get GPT-4 and you can instruct it, and the other models to a lesser extent, although GPT-4 is really good at following instructions. You can instruct it to like give its answer in a structured format, and you can like, you know, get it to answer in JSON, and you can get it to like include a Boolean variable, whether there was an answer in the question or not. And, you know, there's lots of different ways of achieving it, but yeah, these things are instructable or programmable to kind of to give you answers like that. It depends on the model you're using. Obviously, that's GPT-4. We have prototypes, and we've played with, you know, simpler models, and you've got to use different approaches. You know, like a lot of people these days are doing things like getting a large language model to generate an answer, and then they're running a more traditional like classifier on the answer of that to like, so it generates text, and they run a classifier on that text to be like, hey, did it say I don't know, or did it say there's no answer here, or did it give you an actual answer? And using the traditional classifier to kind of like clamp that to a Boolean range. And so yeah, there's lots of approaches basically, and people are getting better all the time at sort of using these models in as kind of engineering building blocks and engineering components.
And what would be your tip how to make that cost effective or performance effective?
Well, so I mean, if you're using a model like GPT-4, cost effectiveness is a major concern. These models are extremely expensive. Now, there's a lot of things you can try and do. You can try and like build caching layers on top of them. That's harder than it seems, because if somebody asks a question to a large language model, and let's say the question has got PII in it, so I might come along and I say, hey, my name is Fergal Reid, and I have a question about how I reset my password. And it will potentially give an answer that says, hi, Fergal, to reset your password, do blah. And you don't want to put like that into the cache. You don't want to cache the hi, Fergal, to reset your password. So, you know, there's challenges here that are unusual for ML systems, because the models are inherently, one, not quite as constrained, like they're very powerful. And then two, is they're not completely predictable. You know, they're not completely trustworthy and predict completely. You know, you'd say to the model, given an instruction like, hey, strip out any PII, but like, we're not sure yet if you can really fully trust that, you know? So that makes simple things like caching take more complex than they might initially seem. And so yeah, I think everybody is working on cost control, trying to, you know, Fin, our bot, it uses GPT-4 for like the core question answering challenge. But then there's ancillary bits, like whether the user said thank you or that helped, or whether they asked like a separate follow-on question. And you know, that's a way easier task than answering a question from an article. So you don't need GPT-4 to do those kind of ancillary bits. And so we'll like use Turbo and stuff to do that. And I think, you know, everyone that's building bots in this area or systems in this area I think, it makes sense to go out first with a model that's as powerful as you need to kind of get the job done, to get into the market, to get customer feedback. And then over time, we're all going to be looking for ways of like, hey, okay, without like degrading the product experience, how do we do stuff like caching or adaptively using smaller models for certain parts or certain queries even. And I expect over time, OpenAI and the providers of these models will eventually produce, cheaper models like they did with GPT 3.5, where, we were using Text DaVinci 3, and then they came out with this turbo model, which was 10 times cheaper. Who knows, possibly a distilled model or something like that, a smaller model that's almost as good. And so, I think we're going to see continuing evolution here. It's going to get cheaper over time.
So that would be another important lesson. How to make it cost effective is there are two ways: caching, which is complex in general due to PII data and not only, and also switching the models, which may require another model itself, right? Because some things will be super easy, some things will be super hard, especially answering from the knowledge base. Cool. And we've got another question from the audience, the question from Christian. I wonder what are both of your thoughts on open source solutions? Is it even possible for open source to go ahead of big companies with often proper founding, data, and compute power? Or perhaps less efficient but cheaper open source solutions are more valid for the market?
Yeah. I mean, I think it's early days yet. I think this is very much still in play. So obviously, like companies like Intercom, we've been doing stuff like we've had an ML bot for a good while before we started building Fin that uses like more traditional machine learning models. And there was like open source or like publicly available neural networks that were like, we used to think were large, and now we no longer call them large neural networks. And they were pretty big, but what pretty big is has changed. And so, we use those. And so, there will be use cases where it makes sense to use those, like with our bot Fin, to kind of shortlist articles that might be relevant. And we use one of our existing solutions with an open source neural network in there. So there'll definitely be some applications for technology that's been around for a while and will continue to be useful. Now, with large language models, we are seeing some interesting stuff like, Facebook had these like Llama series of models, which are, I guess, open source or quasi open source, depending on, licensing and all this stuff. And I think that there's a lot of interesting things going on where you can take like a large model like that and use like a method like LoRa to sort of like relatively cheaply adapt kind of a large language model to get it to like follow your instructions a bit more. And so there's all these variants of Facebook's Llama, notably I think one called Vicuna, I think, which I found very impressive. And so I think there's amazingly impressive things going on in the open source world. Now, at the same time, I have seen a narrative where it's like, oh, these models are better than GPT Turbo, and I don't see that. Our testing doesn't show that. It shows that like they're way better than we expected, and like they're way closer to GPT 3.5 Turbo than we would have expected 6 months ago or 3 months ago, however fast this field is moving. But I think they're slightly overhyped at the moment. Like I think the performance does not seem quite as good to us. So I think it's fascinating, and it's really interesting to see how far people have come by applying sort of like parameter efficient fine tuning methods to some big models, like Llama, or like other even more open versions of Llama, less license encumbered versions of Llama. And I think it's fascinating to see how that goes. But all of those things are really far away from like GPT-4. And, we've seen open source, or publicly funded attempts to train, large language models that compete with the kind of the GPT-3 class models in the past, and with mixed success. And so I would love to see consortia of open source companies training large models, I think they'll struggle to catch, the big labs like OpenAI or Anthropic or Google or whoever, because just those folk are going to probably push the computation up more and more and more, and they're going to get more and more secretive about how they train these methods. But we'll see. And I'd love to see the open source thing advance for loads of reasons, political reasons, business reasons. I guess, it's a good idea to have at least some understanding of this really important technology be open and available for wider scrutiny. So I think, and yeah, I'm excited about it, and I'm slightly more just cautious about it than some of the breathless takes I've seen, which I think have oversold the power of the technologies. But certainly the rate of progress is amazing, and so let's see what happens. Yeah.
Sure. Well, one branch of the research and open source that was quite interesting to me, but I consider underdeveloped, was like a company Fast AI some time ago, focusing on those less known research methods for training machine learning models and so on. I know they were experimenting quite a lot with computer vision at that time, and they had methods for like training models on ImageNet for a couple of dollars. It was like extremely fast training of the model from scratch to actually full performance. They were benchmarking it with the models that were in TensorFlow Zoo, from what I recall. They were crazily effective about that. But I didn't see that developed any further, unfortunately, which is a shame, actually, because I believe that would be a super interesting niche, how to make use of those maybe large models, maybe somewhat smaller models, but actually how to train those models, maybe from scratch, maybe just to fine-tune them, but much more effectively. Because if we compare that to $100 million budget for training the machine learning model, it seems kind out of reach for any kind of open source activity. OpenAI claims that they will open source something soon, but this is quite vague for today. Perhaps that would be the way to make it more accessible, more open. But I didn't see it developing recently at all.
I think the kind of the parameter efficient ways of training large language models we're starting to see emerge, like these kind of LoRa things, are pretty exciting in that direction. Like, so I think they called it Alpaca from some folks in Stanford, where they took one of the Llama models and they fine-tuned it on a relatively small set of data for like, hundreds of dollars or something like that. And they changed the behavior of the model a lot. And so I think that's exciting, and I think that's a big step in that direction. And I can't wait to see how that goes. Like, will we be able to take medium or even large models and then kind of parameter efficient fine tune them to use them to do specific tasks for us? Like, hey, all you do model is summarize conversations, and you're like really good at summarizing conversations. That'd be cool. It'd be cool if we end up with like much more efficient models, like fine-tuned or parameter efficient fine-tuned like that. So let's see. I think that would be an equivalent of the fast AI style stuff, but let's see.
Totally. Fergal, going back to Fin, is there a minimal amount of data that you need to have to start using Fin for your business? You mentioned this excellent onboarding, or at least demoing of Fin, where you can just enter the URL and voila, you can test it out. I was wondering, what is the actual minimal amount of data to make any use out of that? Is there any threshold?
I wouldn't really say there's a threshold in that, Fin is not like a machine learning model where it is fine-tuned on your data or anything. Instead, it's much more like the kind of the modern way of fine-tuning models by putting context into their prompts. And so, like, if you happen to have 3 help center articles that answered 50% of your customer questions, and there will be some businesses like that, right? Businesses where there's like the same question getting asked again and again. Maybe it's a kind of an app where people come use it once or twice irregularly, and they ask the same sort of questions again and again, then yeah, I think you could get started with a very small amount of data. I would say the limiting factor is you want a big enough help center that the bot has got like a good chance of answering the user's question. Like you don't want to put a bot that's live that like has one article in it that comes up one time in 100, because it means then your users are going to interact with a bot where 99 times out of 100 it just doesn't have the information to help them. And that's a bad experience. But I would say, yeah, a relatively small amount of content can get you started, and yeah, and then hopefully we always hope to see like, and we see like a flywheel effect where you know, people start seeing success and then they go and they curate more content. We have tooling to, if you're using Intercom, we have tooling to like enable you to kind of see questions the bot didn't answer because, you know, maybe they come through into your help center. And we're working on like, you know, I think it's fair to say everyone is working on tools that sort of like close that loop more and more. And I think we can get to a state where it's like, you know, I get the kind of the big vision I think people in customer support are trying to race for at the moment with modern AI is like answer each question for the last time, right? Where it's, and so like you end up with something where like you're there, you're doing your customer support, and you know, questions that come in and that fall through to you, the human, and they should be new questions you haven't seen before. And so you answer the question for your customer, and then by virtue of you answering the question, the bot now knows the answer and can give that answer the next time. And, you know, there has to be a little bit of an approval step there for like, you know, make sure the answer that the bot knows doesn't have PII and stuff in it. But I think that's what everyone is racing towards now. And, you know, we won't literally get to that point for a while, but I think we'll get progressively closer to that, to the point where eventually the questions you're answering, the questions your human support team are answering, are sort of like the long tail questions, or the questions that like no bot can answer, because it requires like 5 steps of human debugging, and you got to go and like tap this person over in the finance team on the shoulder to figure it out. And so yeah, I think you can get started with relatively little data, and I think we're heading for a future where that becomes more and more true.
So to get started, the most important aspect is actually to have your knowledge base covering majority, or at least huge part of your support cases, to make the best use of it. And so to ask on the opposite, in the opposite direction, you mentioned that you need to pass this knowledge base as a context to the bot so that it can answer the question correctly. But we know that the context that you can provide either through prompt or any other ways is quite limited. How do you came around that obstacle? Is there maybe a limit on the other side of the fence? Like, what is the maximal size of the knowledge base that you can provide to keep a bot effective?
So basically, we think our customers don't need to worry about that. Basically, make your knowledge base as big as possible, because what we're doing here in terms of how Fin works underneath the hood, and I think this is becoming a standard paradigm very quickly, is, you know, we have a vector search. So when you ask a question, what happens is we take your question, we run that through, you know, a more traditional machine learning system, actually built on the same tech that we built and tuned for customer support with our previous bot, resolution bot. And so what we will do is we'll take that question and we'll use that question with the previous generation machine learning tech to shortlist a set of articles that might be able to answer that question. Maybe that's 5 articles or 3 articles or 10 articles, depending on the question. And then what we'll do is those are what get sent to the big complex slow language model, GPT-4, to actually see, okay, is the actual answer in there? And so this is a very powerful paradigm that I think we're going to see all over the place, which is like you use a vector search to, like, you know, shortlist content that, and it's okay if you put in content that's not related and not relevant there, because then you have an expensive but very smart large language model that can go and like fish the specific answer out of that. And so this feels like an emerging paradigm. Now, we are seeing, like, Anthropic recently shipped the ability to have an extremely large prompt for their large language model. So we are seeing things go the other direction. But even then, I think for cost control, for speed, for like latency, you're going to want to use something like a vector search or a traditional machine learning model to shortlist content that may be relevant. And then you're going to use your expensive big large language model to like sift through that with high precision. And that's a really nice, like that, those are really nice complementary systems, which is why I think you've seen companies like Pinecone and other vector databases raise so much money recently, is because of their ability to complement large language models in this way.
So it's kind of data-centric divide and conquer. Nothing new in IT in general, but something that needed to be adopted specifically for data-heavy applications, and where you couldn't do that with a single if or something like that.
Yeah, I mean, broad phase, narrow phase, like it's like, you know, it's like you're building a physics engine for a game or something like that. It's like make the short list of possible colliders and then run the expensive algorithm to check them. You see this paradigm all over CS. Yeah.
Okay, so I have one maybe final question, because we are approaching the end of time and that we have for today's episode. I see that this generative AI in general introduces kind of a serious paradigm shift in the data world. So you can integrate an API from OpenAI and voila. Are data scientists still needed? Does the role change? How this role changes? How does that look like from your perspective?
Yeah, I mean, this is something our thinking is evolving on all the time. And, you know, obviously I'm on the machine learning team, and then we were joking recently after work. It's like, oh, what's your post AI job going to be? Plumber, electrician, and so on. But you know, like so far, I think that the tech we've seen so far has probably increased the value of a data scientist or a machine learning engineer, or however you call them, in that, like, you know, you can get a lot more done now much more quickly. You can build a prototype and put it live with a large generative model like GPT-4, GPT-3 Turbo extremely fast. And I would almost say, like, for a lot of application domains, these are amazingly high leverage prototyping tools. You can build your first version super fast and then put it live and check, does it answer people's questions. And we've noticed, like, people on our team start to do that. They're like, oh, I could build a classifier here, or I could just write 2 sentences for GPT Turbo with the sort of behavior I want, which is like, you know, find the most relevant questions, or find the shortest questions, or the, you know, the questions that have the highest sentiment. You just write it in English language, and it's like, it won't follow the instruction perfectly. Maybe it won't be as good as a classifier, but it'll be almost as good, and you can deploy it instantly. And then that serves as a prototype. If that works and that's delivering customer value and it worked out as well as you hoped, well, then you can come back and you can build your traditional machine learning classifier there, which is going to have much lower cost to run, much lower latency, much more tunable performance characteristics. And so I think overall so far, it's an amazingly high leverage technology that sort of like just enables existing specialists to do more with less. Over time, as it gets more powerful, engineers are probably going to be able to do more who maybe aren't ML specialists. I think they're still going to be quite analytical for a while. Eventually, over time, someone that's more shaped like a product manager is going to be able to do more than they can do today. And who knows where this will go. But I think at the moment, it increases the value and the leverage of anyone who's kind of like an ML engineer or a data scientist.
Yeah, but it still sounds like you can leverage those generative AI models for prototyping, as you mentioned. And so you can quickly deliver some proof of concept, validate that with users, experiment on that, and so on and so on. Check whether it actually would bring the value for your business. And then if you see that it could become something serious, but also a serious cost for your business, because GPT-4 isn't cheap, you would wonder how to switch to something that will be much more cost effective. And this is where machine learning engineers and data scientists will come to play, because you won't be able to solve that actually without this kind of support.
Yeah, absolutely. Now, maybe in future, GPT-4 will be 100 times cheaper than it currently is, and that'll become less worth doing or something. Maybe it'll be open source models. We'll see. Yeah.
Sure. So one final question from the audience, and I believe we will sum up. So question from Christian: did you need a dedicated prompt engineer role for building Fin? How much work in terms of prompt optimization you had to do in order to achieve required result? Do you plan to experiment in that area?
Yeah, so I mean, the joke on the machine learning team, my team, is that we've become the prompt engineering team instead. And I think initially we were like, is this what we're going to do for the next 10 years, write prompts? But reassuringly or otherwise, I think, you know, we've realized that, like, no, to get cost control, fine-tune control, and so on, all our hard-won skills are still valid, at least for a while. But we've spent a lot of time doing prompt engineering, and yeah, we have to do a lot of prompt optimization to get the desired result. And you know, these systems can be very sensitive to small changes in prompts, and so we spend a lot of time experimenting and back testing and like checking that, like, okay, we want to change the prompt to make it more X. Okay, now we've got to run a back test to make sure we haven't degraded something else it can do. And prompts they're harder to use than you think. Like they have a carrying capacity. You put too many instructions in a prompt, the prompt kind of gets smeared out, and like some of the instructions don't get followed as much. There's ways of like chaining prompts together. There's ways of like, you know, chain of thought, like getting a prompt to show its workings, increases its accuracy. Like there's a whole art to this. And I definitely think my team has developed substantial expertise in this area. Which is maybe not something we asked to do, but something we have just had to do to get the performance we wanted. And so I think sometimes it's more of an art than a science. Sometimes it feels like people always joke about how, programming is like spell casting, and we're like, we've got a new magic spell. We don't really understand why it works, but it works in the back test. And there's definitely, you know, but immature technology is always like this. It's always like a bit of art and a bit of science. That the science normally doesn't come until way afterwards. And so I bet like either the models are going to get so good at following instructions, prompt engineering is going to get easier, or like there's so many ways this could go. I'm not saying prompt engineering will be around in 5 years, but I think at the moment, yes, tweaking and playing with your prompts is often worth doing. And sometimes you can get like a smaller model like Turbo, GPT 3.5 Turbo, with the right prompts and with like examples in the prompt. It's really good at few shot learning. You can get it to give you like performance you thought you couldn't, and you can use a cheaper model. And so yeah, we're spending a lot of time on prompt tweaking and tuning at the moment. Maybe engineering might not be might be too generous of a term. Prompt hacking at the moment. Yeah.
Okay, thanks for your answer, Fergal. Thanks for your time today. So summing up, those few important lessons that we learned today is that you need to constrain any application that you are creating with usage of GPT-4 or similar techniques to actually make sure that it cannot be exploited, to ensure yourself some kind of a cost control. And also to make sure that it doesn't get into hallucinations. And you can do that with providing your knowledge base as a context and constraining the model to not to go beyond that knowledge base at all. Sometimes you can use supportive models to tell whether this article or this answer is in the knowledge base or not at all. And this may be like extremely useful. And this is the area where you will still need data scientists and machine learning engineers in the following years, because someone needs to ensure this cost effectiveness. And this is the area that is still a domain of this old good machine learning, you know, with classifiers, with classical models, and so on and so on. Thanks, Fergal.
Cool. Thanks very much for having me, and thanks everyone for tuning in.
Yeah. Thanks to all the audience as well for being with us for the past hour. Have a good one.